VLPSos here. This is a video lesson for Python programming images. I've started this code file from stub1. I won't be importing or loading sound resources, so I've commented out the initialization of the mixer. In the folder that has this code file, I have subfolders for sound effects and also images. In this program, I'm going to load 2 images and use them and display them on the screen. I have those images in an image subfolder. I'm going to load my first under a comment load resources, which is after the screen settings and the colors that are being imported from the file that is in the same folder as this code file called palette. And I'm going to load my resources before I use surfaces. Very often we make surfaces or compose surfaces from the graphic resources that we load. So we want to load them first. And we begin by setting path equal to the call from the OS module, the getCWD function, so that path is now equal to the current working directory where this code file exists on my computer, which is unique from computer to computer. We need to know the path in order to load resources, and we're going to use it to load a graphic that we're going to assign to be the variable picture. Picture is going to be equal to a call to pygame.image.load. And this load function needs the path and name of the image as a string. And we compose that string with the %s, which the variable path will take the place of, and then the subfolder that the image is in. And the name of the image, this first one, is called Heather Backdrop, a digitized drawing from Heather Broden-Geely, who has provided it for us. The variable path replaces the %s, which is unique to each computer, and the file type, in this case JPEG, needs to be a part of the name of the file. If we save and run, we get no errors, but it's good to check when we load new resources that they are in fact loading. And if we don't have an error on the load, then we assume that it works. But we can't see that image until we blit the image to the screen that the user sees. This image is a surface. When you load a graphic, it is a rectangular pixel matrix of color. And we can treat it like a surface, just as we use other surfaces. The screen, I tend to call the primary surface. When we run the update function at the end of our frame loop, it's the screen that gets updated and displayed in the window for the user to see. So we have to put the graphic surface that we loaded onto the screen and then update so that we can see it when we run our code. I'm going to do that under the draw comment, the draw objects comment in the frame loop. I'm going to first fill the screen with black. This is like erasing. And colors we have imported from a file named palette, which is a palette of, it's a dictionary called palette, and the keys of that dictionary are the names of our colors. So we fill the screen black, and then we're going to blit. Blit is a function, and the name blit means to put one rectangle of color onto another, to put one surface onto another. So we're going to blit to the screen, and what we're going to blit is the picture. And the second part of this argument is the tuple of 2, which is the location of the top left corner of the picture that goes onto the screen. So it's a location on the screen that the top left corner of the picture surface gets blitted to. And we're going to choose that for the moment to be 0, 0, the top left corner of the screen. So we're matching top left corner as a picture to top left corner of screen with this bit location. Let's see what we get. We got an error. It's to make sure that we imported palette. Spelled correctly. It's not, because when I used it, I used 2 L's instead of 2 T's. Now when we run our code, do we see the image on the screen? We see some color. It's not filled black. There's blue. It looks like fog in the sky. We did blit the image. If we take a look at the image in the image folder, the actual file that we're loading, it looks the same size as the thumbnail in the folder. But that image is very, very large. When we blit the top left corner to the top left corner of the screen, what we're seeing is just the amount that the size of the screen can show of the image, which is just the sky in a picture of a castle scene with the sky at the top of the picture. What we see in the graphics screen is just a piece of the picture. We can check the size of our picture within our code. We do it like this. After it's been loaded, we can use the get width and get height functions on the picture in order to determine the dimensions. I'm going to print them. Picture.get underscore height, which is a function, and close it. Now this print is going to print in the interpreter. This is information that we're using as the programmer. It's not the user that will make use of this information, but we can see that our code knows the pixel matrix to be over 13,000 pixels wide and almost 7,000 pixels deep or tall. That is a huge pixel matrix. So we can see that when we blit a picture onto the screen, there's no automatic adjusting for the size of the screen. If we wanted to blit a picture onto the screen and have it fit perfectly, then the size of the file would have to match the exact size or dimensions of the screen. We can do something with this picture to see a different part of it. We're going to adjust where we blit the very large picture in order to see the middle. And to prepare for that, we're going to declare a variable called picture blit location. And we're going to base it on the picture width and the picture height, which we found when we printed. But instead of printing, we're going to set variables called picture width equal to the function that gets that width of the picture, and the same thing for the height. So these variables now will remember or stand for the dimensions of our picture. And we're going to use that to create a tuple which will be the picture blit location. Our intention is that the picture blit location we're going to use when we blit it. the top left corner of the picture is going to go to a different location than 0, 0. Picture blit location then is going to make use of the screen width. It's going to make use of the variables picture width. And we're going to divide the picture width by 2. And make use of the picture height. And we're going to divide it by 2. So the blit location now is based on the dimensions of the picture. If the picture was so wide, then we're going to take half of that width. And we're going to do that with the height as well, take half. Right now, the blit location, if we used it, we can observe what's going to happen. If we get the syntax, we have a warning about the blit location being an integer, but that isn't affecting what we see. We see nothing but black. And the reason for that is because the screen is receiving the picture, but the picture's dimension of where it's being blit is based on the size of the picture, half of it. It's a coordinate that has positive x and positive y values. The picture is being blitted way off to the right and way down off of the screen's dimensions. So we can't see the color of the picture. However, if we change our blit location so that these half of the width and half of the height, this location is the negative values, then we're going to blit the top left corner off the screen to the left and up from the screen's 0, 0 location, which means that the blit location of the picture is way off the screen to the top left, and the rest of the picture is then going to be displayed, so to speak, but the picture, the screen, will only capture a small section of the middle of the picture. Again, the blit location is chosen with negative values based on the size of, or the dimensions of the picture, so that it is blitted off of the screen, so the rest of the picture then comes into the screen's location and we can see the middle approximately. When we run, we see what looks to be like stone brick. The picture is huge of a cityscape, medieval cityscape, and it looks like we're seeing maybe the wall within the middle of the picture approximately. This warning is giving us a reminder that the blit location ought to be turned into integers and not floats, because we can't have fractions of pixels. We don't get the warning, and we see the middle of the picture. Without software or programming something more sophisticated, we're not going to see the entirety of that picture. It's too large for a screen to show. Even if we increase the dimensions of the screen, we literally would not be able to fit it on our monitor. So we're going to switch to a picture that is much smaller. We're going to load the second picture that we have in our images folder. It has a different name. Its name is Sauce Mom, and the dimensions are part of the name of the file, 640 by 480. And its file type is JPG. Notice that sometimes the file type for JPEGs has 4 letters, JPEG, and sometimes JPG. It depends on how it's saved on the computer. It does matter. If you're not able to load your image, it might be because of that subtlety. We have a different image. We called it picture. And now if we're blitting it in a negative coordinate to the left and up, the picture is being displayed, but the screen doesn't capture but a corner of the picture. This picture is approximately the size of the screen, so we don't need to modify the blit location. In this case, we'll comment that out and redefine our picture blit location to be the origin again. Let's see what we got. We can now see all of the picture. It's smaller than the screen, but the top left corners are lined up. We're going to center this picture, and we're also going to improve the presentation of what's going on here by using a surface. We're going to fill the screen with a backdrop of color and then use a surface to center the picture on, and then blit that surface so that we can see it as a nice presentation. To accomplish this, we're going to make use of a surface. The code's already been written as a comment. We're going to call this the picture frame. That's what the picture is going to be blitted to instead of the screen. The picture frame size is based on the screen width and the screen height, but we're subtracting from each dimension 2 times this variable border. Border is going to be the size of the pixels all the way around the picture frame. So we need to define the size of that border. It'll be 10 pixels. Now that we have the picture loaded and the picture frame surface created, we're going to make a composition of these. We're going to fill the screen black. We're also going to change the fill of black to yellow. The picture frame surface we will fill with black. And we're going to blit the picture frame to the screen. So the screen is receiving the picture frame. And the location of the picture frame on the screen will be based on the border. Spelled B-O-R-D-E-R. Let's see what we got. We haven't blitted the picture anywhere. We've just dealt with the picture frame and the screen. What we have here is we have a yellow filled screen behind a surface, the picture frame, that's blitted at a coordinate to make the borders of 10 pixels even around the edges. Now we're going to put the picture that we loaded into the middle of the picture frame. It's the picture frame that we will blit to. What we're blitting is the picture, and we have the picture blit location that we will use from before at the origin. Let's see what we got. So the picture and the picture frame, which is a black filled surface, the upper left corners are lined up when we blit the picture at the origin, the coordinate 0, 0. And then we have the screen yellow border behind it. We want to center this picture now in the picture frame. We're going to change the blit location and make use of the one that we prepared before, but it is not going to be based on, it will be based on the picture width and the picture height. Let's see what changing the picture blit location to what we had written before does to our picture. It's negative. It's blitting it to the left and up. So we're going to change this blit. We want to base it on the difference between the picture frame size and the picture width. Picture frame size is going to be a tuple of 2, and we find the difference with subtraction. Once we find this difference, we're going to divide by 2. And then turn it into an integer. We're going to do the same thing to the height. To prepare our picture blit location. A little more explanation on this rather sophisticated argument. There's some math being done. We have the integer function because this is going to be a pixel location, so we can't have fractions of pixels. We turn what we got into an integer for a location. What we're turning into an integer starts with a difference. There's a picture frame size and a picture width. And we can see that the picture width is slightly smaller than the frame width. What we want is we want the difference between the two. And then we're going to have that difference. If we want to center a picture in something that is larger, then we're going to center it by taking half of the difference between the widths and bumping it over by that amount. That way it'll be centered horizontally. If we have a difference between a picture height and the frame height, then we can center it by bringing it down by half of the difference between the two. This is the math that accomplishes that, but we need to base it on the picture frame size, which is a surface. So let's make sure that we have a picture frame size. We created the surface and made it this size. That's the picture frame size, the size of the surface when it got created. We can program a little more dynamically if we copy what we said was the size and we set it equal to a variable we can call frame size. Well, we called it picture frame size. The picture frame size now is used when we create the surface and when we refer to it in order to center the picture. Let's see how it works. We had a border that was used in creating the size, so we have to define the border before we use it. And not after. We have a picture on a surface, the picture is centered, and the whole thing is then blended to the screen, so the screen is seen filled yellow as a border of 10 pixels around. A nice presentation. Now you have seen how to prepare a subfolder of image resources, incorporate them into your program, and use surfaces to manage their display. Use 2 images of your own, one large, one very small. Make a simple program that displays the large image as the backdrop of your graphics display, and use the other as a mouse cursor that replaces the standard OS or operating system arrow. In other words, choose a large image that can serve as a background, not larger than the screen itself necessarily, like in this example, but an image that can fill the screen, and a very small image that you blend at the mouse location that can be moved around as the mouse cursor. Remember to turn off the operating system's mouse so that you can see your image more clearly. Have fun.